Hey, hey, what's up? Am I on? Let's see. I think I'm on. Alright, thanks for tuning in. Let's get started. So, today, I want to do something fun. I've been working on a side project doing this for the past month or so. Really just experimenting with a ton of different things. Long story short, I want to make a question answering model similar to ChatGPT, and I want to use podcast data. So I found this sort of neat. I already did this in another fashion using other podcasts, but I want to use some podcasts, some relevant tech podcasts, different podcasts George Hotz is on. I know some of you guys probably like him. I'm a fan. And some Lex Friedman podcasts. He has some, interesting people on there. And overall, I want to just sort of make a ChatGPT that's like a smart 10x senior developer. So let's do it. Let me see. Am I yeah, I'm good. Connection's good. All right, so let's call this. What should we call this? Let's call this Tech Bro GPT. All right, so the first thing, before we get too into this, I'm gonna get into the type of model that we're gonna be building out. So we're gonna be building out misspelled that, a retriever reader model, and this is going to be open domain question answering. So let's go to some documentation here. I can sort of describe it, but I like to kind of run through docs so you guys can understand kind of what we're doing here. So really, what a retriever reader model is something in architecture that, for question answering interfaces, that retrieves documents that you're going to need. So in the open domain realm, let's say you don't fully know they don't fully know what you're going to be asking and what document's going to be relevant, so they have to have. So what we're going to build is we're going to have a model that retrieves documents based on some sort of algorithm that's relevant to your query. So if I ask for, if I'm asking for something related to lions, then I have to have some sort of corpus in which I can quickly see what are the top end things that are related to lions. And then the reader part, this is more simple. This is kind of just, it gets the retrieved context, and it gets the question, and it tries to figure out how to actually answer the question. Really, I'm just gonna, for simplicity's sake, for the reader part, I'm just gonna be using llama 2 to generate. Be prompting llama 2 using the context we retrieved from our corpus to generate the answer. I already have a lot of this stuff built out to some extent in a separate arena, but I'm gonna be moving some code over for the retriever reader, running through exactly how it works. It's super simple, very simple Python classes, nothing too crazy. And then I'm going to be first running through how to actually get the data set. So how are we actually going to get... so let's start with George Hotz podcast. If you don't know him, he's one of the guys who first cracked the PS3 and iPhones. Smart guy, and he has a lot of really cool podcasts on AI. And he has an AI company. And we're going to use one of those podcasts. So we want to make something that's like ChatGPT, but a little more focused, and that can intelligently answer questions based on our corpus of documents. So let me search this guy. All right, so I added this George Hotz archive. I'm realizing this is like not an official page, so my bad. All right, so let's actually use this one just to kill two birds with one stone. Let's use this one with Lex Friedman. There's a couple of things we can do here. So
what possible ideas do you have for
let me turn that shit off. Okay, so a couple of things we can do here. So in this conversation, we talk about some cool topics like GPT, AGI, self-driving. We can use OpenAI's Whisper, which is a audio encoder. Let me just make sure I'm getting that right. But it's an audio encoder that we can use to recognize speech in audio files, which is pretty easy plug and play. This is something that OpenAI gave us, and it's actually pretty cool. It's open source. So we could use this, and we can use one of their larger models because it's a simple video. I don't want to use like some crazy or I don't want to like do like a ton of different podcasts because we don't have a lot of time. So we'll probably just do this one for now, and we'll I like to just do it first with a small set of data like I did on the last video where I was fine-tuning the code. But yeah, so what we want to do, so there's actually another thing we can do, and as you know, I love web scraping. If you're 10x, you web scrape, okay? If you're not 10x, you don't web scrape. That's that's how it is. No, you're 2x. If you don't know how to web scrape, you're barely an X, okay? But so what we can do is, I believe his podcast actually, they have the transcripts here, so we can just like yank this down. Oh, it's auto-generated, so that's actually a problem. Let's see if the English default is this gonna load. This might take time to load. Let's see. Oh wow, this page loading the transcripts is taking a bit. Wow. So what we can do is we can manually just scrape these transcripts here. But this isn't going to be the case.
Way to me is wireheading.
Let me close this.
We end up with.
But so like as you see, they actually have the transcripts here, which is nice. I'm not going to do this. We can just scrape this, so we can use this as a data set. I'm not going to use this for now because a couple things. Most videos aren't going to have the transcripts loaded like this, and I want to show you how to actually get it from the audio. So there's actually a really cool, I'm just going to steal some of my old code or my code from a couple weeks ago, just so I don't have to rewrite it. That's life. That's life. So let's take this. So we're gonna get Whisper. I don't care about generative AI. Alright, so, and I'm gonna get YTDLP. I will explain all these things in a second. Let me see. Yeah, and then this is just the command to run it from a YouTube video. We're going to be placing a different video there in a sec. And then we're going to import Whisper. And so I'm going to run through all this code. We got to cover a lot of stuff, so I wanted to come prepared. And the transcribing, like you see, they already did the hard work to train the model. We're just code monkeys that are abusing their model. We're engineers. We're builders on top of these things. Okay, so that's actually all we need for now. Okay, first line. Actually, before I do this first line, I know we're gonna need transformers, so I'm gonna just install Transformers, which, if you don't know, Transformers is Hugging Face's model. Hugging Face's library for dealing with all their Transformers libraries, pre-built libraries. It's really cool. It comes with a ton of stuff that's like awesome. You gotta be on the Transformers game. I mean, there's so much tooling around there, from inference pipelines to training, loading pre-trained models. Their trainer is amazing. Tokenizers. Anyway, so loading data sets from Hugging Face. I mean, there's just a ton of stuff. We're gonna just keep this is gonna stay here. So we're gonna use this to get llama and fine tune it. Oh, we're actually not gonna fine tune it. We can fine tune it. My bad. We could fine tune it. Maybe we'll do that another time. But we're just gonna get llama and make predictions, and I'll just say, just to be clear, and generate tokens. Okay, so OpenAI Whisper. So this is a speech recognition model for parsing the text from audio. Like I said, we already have the transcripts here on the page, and it's actually labeled by time, which is nice. YouTube is giving us that. We're not going to do that here because I just want to show you kind of how this works. So YTDLP, this is a YouTube downloader script that uses ffmpeg to, I believe, pretty sure, let me just double check. Pretty sure this uses ffmpeg. I kind of forget if it does or doesn't, but whatever. Okay, that uses ffmpeg to download. I'm not even gonna mention ffmpeg. It downloads YouTube videos. We're gonna download just the audio right here, as you can see. Let's just call it output 1, and let's put the YouTube video in. So let's paste that YouTube video. So let's actually just run all this stuff. Let's connect to the machine, run all the stuff, and I'm gonna load up the retriever reader stuff in a sec from another Colab I have. Let me know if you want this code. Just comment or just reach out on GitHub, and I can make a repo up for whatever you guys request. Okay, so install this. This is using the module to install, the pip module to install here. Actually, I don't know why. I don't know if there's something wrong with their setup py. Or not wrong with it, or if it's just not, it's configured weirdly. Okay, so let's install this Whisper thing. Let's install this. And let's just run the, let's run the YT downloader. This YT DLP thing, this is going to be, we're going to use this to get the audio output. So this is going to take a little bit. So I'm going to talk about while this is happening. Let me just make sure it's downloading fine. Yeah, while this is downloading, oh wait, did it already download? So let me just talk about retriever readers for a second. And let me talk a little bit about, actually let me talk about vector databases a little bit. Maybe, let's see if there's a graphic online. Can educate the people. Y'all people need to know. You get educated. Alright. So is there like a graphic I can use? We talked about word embeddings in another video. I can talk about it again. But long story short, let's find a good graphic. It's kind of cool. Is there another one? What is this? Yeah, this is a good graphic. I mean, it's, real simple, real dumb. We want to get dumb. We want to get as dumb as possible. You gotta be dumb to be smart. All right, so where's that graphic? Damn, my computer's so slow. So vector databases, long story short, just waiting for this graphic to load up. So vector databases are this new concept. Well, it's not that new. It's actually not new at all, but it's a new, fever around vector databases, which essentially all stem from this right here. You see this little vector? This process is where you're getting real world data. Here they have image data, they have text data, they have audio data, and it's called learning the representation through these transformer models. And it doesn't need to be a transformer model. These are really good at learning representations, or learning the meaning, I suppose, the semantics behind the data it's getting. And as you can see, there are image transformers, NLP transformers, audio transformers, transformer models that have been trained on a ton of different image data versus a ton of different word data, NLP, and a ton of different audio data. And in the end, they understand these patterns so well that in the end they can actually tap into that output layer to give you the logits for whatever you pass to it, and it can give you the vector representation that whatever word you pass into this model, what it means in numbers. A better way of saying that is like, for the NLP one, which is probably the easiest to understand, they use these transformer models to read like billions and billions and billions of news articles and Wikipedia articles and books, and after that it understands words so well that if you pass it something like, the cat in the hat or some sentence, it understands what cat is, what in is, and the positioning and hat so well that it's going to give you numbers that represent that sentence with the understanding of what a cat is in relation to all the different uses of cat and the other words in it. So that's why it's like, 0.1, -5. These are random numbers, but long story short, what we're going to be doing is we're going to be using pre-trained model to embed a ton of we'll use sentence transformers for now, but we're going to use a pre-trained model to embed a ton of text, which is going to be the podcast text. We're going to chunk it out first, and we're going to embed the chunks, and we're going to embed these using something that was trained on a ton of different data, so that when George Hotz is talking about whatever he's talking about here, the interesting thing about humanity is the diversity in it. Oh yeah, organisms in general, whatever they're talking about, we're going to have such a good understanding of what they're talking about here, what humanity is, what diversity is, what all these things are, that the embeddings are going to hold that information. And when we, in our retriever, to go back to the retriever part, this is still downloading, but to go back to the retriever part, let me go back to, I don't think they have a good graphic on it. But either way, retriever, I can just talk about it. When we go back to the retriever part of things, we're going to be doing cosine similarity again, like we were before. in another video to find the top matching context, so the top matching document related to the question. So it's like ChatGPT, it's a question answering experience, dialogue. The user's going to ask a question. We're going to look at our embeddings, our podcast embeddings. We're going to fetch the context, and then we're going to prompt Llama 2 with saying, answer our question using this context. So it's sort of informed by these podcasts. And the more podcasts we add, the more diverse the data set is, and the smarter the model is going to be. This is our tech bro GPT. Even though I don't think we're not using GPT. It's just kind of being stupid. Alright, okay. So we loaded up our model. So it looks like we actually did download the MP3 of this video, which is a 3-hour video. So it should be a decent amount of text. Let's load up. Like I said, this is super easy. Like all these, we're using models that were pre-built. We're not really, last video I was fine-tuning. We're not really fine-tuning anything here. We don't have to. So now it's actually transcribing the, oh interesting, I'm on CPU right now. Why am I on CPU right now? Because I don't have any more compute units. What the fuck? Okay, what the hell? My phone. I'm not gonna pay for that on here. Let me buy some compute units before we go any further. Well, yeah, it'll make it a better experience. I'm wondering if I even need to. Yeah, I'd say I probably should. So what this is, I just ran out of compute units. Every time I use Colab, I just feel like I'm in like a Blade Runner-esque sci-fi world, and I'm like buying my like little digits of the day. I'm buying like my coins, my digital tokens to like let me eat today. I gotta re-up on my tokens. Okay, so let me go here and let's connect to this. I just need to buy like $10 worth. I'm not ignoring you. I'm just looking at the phone. It's like YouTube is like so often I feel like streaming, it's like your attention, it's almost like with a girlfriend where it's like I'm on my phone, but I'm paying attention. I promise. Okay, so let me just buy it. I may have to refresh here. I may have to reconnect this. What is this? Let's go. Let's see. Let's exit out. So I just bought some. Alright, cool. 100 compute units. We will have to reset this because I'm not doing this on a CPU. So let's click GPU A100. We're gonna have to disconnect from the timeline, from the runtime. Alright, that was a little, we're gonna have to redo all this. So isn't that fun? Isn't that fun how everything takes so goddamn long in the data science world? Isn't that great? I was complaining about that last stream. It's like if I started out doing like coding and I started out doing AI, I would never actually get anything done because I'd be like, oh, this is boring, I'm gonna do something else. Oh, this sucks. Okay, so the reason why you don't want to train things or run inference, make predictions on CPU, is because CPU is very bad at doing things in parallel. It's very good at efficiently using memory, a lot of memory to do tasks. That's CPU is great at memory. It's great at holding memory. It's great at manipulating memory and being in a safe space. But GPUs are built for graphics, which is all based on matrices and matrix multiplication and doing math in parallel. Trying to find the right term for it, but just doing a lot of math at the same time. That's why people are chasing down these GPUs right now. It's because whenever you're getting, the reason why your gaming laptop needs it is because to render graphics, like what are graphics? They're images. What is an image? It's matrix. The way you represent images is in a 1,000 by 1,000, whatever dimensions you have, field of numbers, and you have information encoded into each little pixel on what needs to get displayed. So when you have to keep rendering different images, and this is a high performance game, you're going to need a very intense graph GPU to do all that matrix multiplication and just manipulation. So that's why GPUs are important, is because the root of how neural networks work is backpropagation. So you have this big matrix of numbers, and then you have slight, calculus modifications, gradient descent, as people are talking about, that's happening to all these numbers at the same time. And you have to do that in batches, right? So you're going to have to do that for, let's say you have, like we have one transcript, let's say you have, and we're chunking it out. Let's say for our transcript, we chunk it out to like 1,000 different, paragraphs. For each, what if we want to do each paragraph at one time? Well, that's going to be kind of slow. What if I can say, let's actually do 8 paragraphs at the same time? Then you're doing it 8 times faster. And it's not even just that it's faster, it's that you can learn after seeing 8 examples. So that's why batches make a lot of sense and work really well with hey Tony. Yeah, is tomorrow good? Tony, can you? By the way, Tony's for anyone watching in the chat, Tony, he's a machine learning engineer. Wait, Tony, what are you coding? What are you coding? So, like, I'm just describing gradient descent right now. And why batches, it's for speed, but it's also, we should talk about DPO. I still haven't gone down that, yet. Right now, I'm essentially, really? So right now, I'm training this, I'm using Whisper to read podcast data, reading this podcast with George Hotz as an example. We can actually just scrape this transcript, but we're just using Whisper to get the podcast data, and eventually we're gonna use this to it's taking time. We're gonna use this to essentially create a retriever reader model. So we're gonna embed, using sentence transformers, embed the podcast, and then use a query to Trying to test unfreezing. Oh wow, for real? Wait. So it's not PFT. Are you using PFT? No, dude, I'm liking the engage with the stream. It's cool. Yesterday on the stream, I was messing around with fine tuning llama using a LoRa using PFT, which is Hugging Face's library for parameter efficient tuning, and I had a lot of luck with that. It was only using Tony. It was only using 12 gigs of GPU RAM to fine tune with it was only 2 batches. It was actually pretty crazy. You should try it out on Colab. Oh, it doesn't support 8-bit precision. Yeah. Let me think. I can show you, dude. Watch the video from yesterday. We can code it tomorrow. Me and my buddy Nick, he was in the chat yesterday. We're gonna be coding tomorrow. Let's meet up so we can figure out. Cause yeah, it's actually really simple using PFT. They make it super easy for you. There's a script. So look up StarCoder's fine-tune script. Look that up. They have a fine-tune.py. I just adapted that and just used llama, and it worked really well. It does a few things. So it does the LoRa config, and it also it does the 8-bit. There's some other thing. I also did the 7 billion one, by the way. I didn't do I did the smallest one, so. But yeah, it was only 12 gigs. Or 13, something like that. Alright, this is taking some time. I don't know why this is taking so long to transcribe. Let's see. It's fine tuning. Oh, well, I think the 15 gigs should be fine too. It was fine tuning Llama 2 to code like me. Because you can tell it the rank too. So you can tell it what rank to use, because it does the low rank adaptation. And then you can pick a really low rank. It picks 16, which I don't know. I don't really know, like, that's like 16 columns or whatever, but I don't know how large that number can be. Damn, it's taking a while to transcribe. Well, I guess it's a 3-hour video, so that makes sense. Yeah, so that video is good. I feel like that's utilizing, because so many people are making fine-tuning videos, but they're not, a lot of people aren't doing the LoRa, which seems like, the thing is, I haven't trained it with enough data to actually get, like, a good outcome yet. I just haven't done that yet. All right, let's see. So once this is done, well, before this is done, I'm gonna grab my code that I wrote for the retriever reader. So I have a little retriever reader model or class that I wrote, which is, let's see, Colab. What is it called? What did I call it? I have so many little random projects here. It's so slow. Yeah. So that, look at the LoRa config. I should send you that script. Let me know if you want that script. I can send you that after the stream. Let's see, where did I definitely made, where did I, I saved that locally. So I have some, I'm like learning Rust right now. It's so weird learning a new language. It feels weird. Like after using the same stuff for so long. Like I haven't genuinely learned a new language in like language, not framework, in not that long. I learned not like very well, but I had to learn Go a couple years ago. So I think, where is this? I have a, let's see what, yeah, definitely check out I have two videos. I have one video which is the 4-hour one before, where I actually, you can skip the part where I get the data set, but I have a part where I figure out how to code, so I'm trying to fine tune it to code like me. So really all I'm doing is I'm making a data set that's like from my code, and then I'm fine tuning the model, fine tuning it with these prompts using these like little tokens. But really it's just based off of different code files that I have, and then I label them based on the project name. So I have like you can skip the part of that video where I build the data set, because it's just like a node script to do file reading. But like after that, I take starcoder's finetune.py, and then I rewrite, well, I just adapt it to use my data set, and then I configure some things, because they have like the whole PFT LoRa setup. All right, let's see. What did I? I think it's an experiment. Is it base query? I have like so many random projects. It's not base query. Is it my index? Is it? It might be my index. No, it's not. Is it code helper? Wow, I've been making so many projects. I literally lost this. I lost this project. Oh no, it's this base query. No, it's based index. Yeah, this is it. Okay, so I made a little like retriever reader thing. It's really just like, it's super simple actually. It's just like, I'm gonna take all this stuff, all these classes, and move this to GPT. I'm calling this Tech Bro. They're calling this Tech Bro GPT. Tech Bro GPT. Okay. So this is just a class for the document, and I will run through all this. But I have a class for the document. I have the class for the encoder, which is the encoder is just sentence transformers in code. This is just a basic vector database is what we're building here. Oh, whoops. Then I have one for the index builder. So this is the where the magic happens. I think this is where I chunk everything too. Oh, I have to download sentence transformers. I have the reader. The reader is just doing prompting. Oh, I actually have. I'm only doing it using the inference API. I gotta change this to use a local thing, which we'll do later. Alright, so I just added all these files. I'm gonna run through all these files and then we'll make it work. So let's see. Yeah. So let's install sentence transformers. So I'm using sentence transformers to get the word embeddings. Sentence transformers is awesome. It's really cool. So we're gonna use this to. They get pretty much all the transformer libraries they have. They make it very easy for you to encode, to pretty much generate embeddings for. So this vectorizing we were talking about. They make it really easy for you to generate these embeddings for sentences. It's awesome. And I just realized I don't know what's the word count. Oh wow, there's 33,000 words. Wow, they talk a lot. George Hotz talks a lot. Wow, that's a lot of words. 'Cause I was looking at other podcasts. It's typically like 10,000. All right, so I'm using this QA one. This uses dot score. So actually, we're gonna be doing a dot score ranking, not cosine similarity. I just realized, am I using cosine here? Let me just see. Let me just make sure I'm not. No, I'm using dot score. It's another way to score these embeddings. So this is like a very basic. So you like LangChain, you like all those llama index. This is the most basic setup for that you can get. That I wrote myself because I was using llama index. I don't know if anyone uses llama index, but like it breaks so much. I loved it while it worked, but it just like that's what happens with all these new projects. Is there's like they're getting worked on so much that things just break so easily. Anyway, so this is a very basic class for the documents. So we're going to use this class on each chunk that we get. So we're going to chunk everything, which we're going to do in here. So we're actually just going to have one document, and the document is going to be for the transcript. And the document, it just takes in the file, which we're going to have to save. Actually, let's save that. Save that to a. Let's do. Well, we don't have to save it to a file, but I just set this up to read files. So. Okay. Let's see if this is fine. And did it save the file? And it saved the file. Cool. So now we saved our output text, and now we have so we're going to make a document. So the way I set this up is you have a document class, and for each document, so whether it's a Wikipedia article or like here we have whisper output is like the first type that I have here. For whatever document it is, you load up the document and then it chunks it out based on sentence count. So I'm just saying per 5 sentences, chunk the doc. This is so that we don't just have one big embedding, and we can embed each chunk, and then we'll do the dot score for each chunk. And by the way, Tony, if you have any questions, definitely let me know. Because I was learning a lot of stuff last night when it comes to that, like a lot of new concepts. There's so much new tech with all of the, especially fine tuning, and with the LLMs, especially when it comes, like LoRa is such a new concept, and there's already tooling around it. So I mean, you probably know better than I about a lot of that stuff, but let me know if you have any questions about how I set that up. So the encoding, this is super simple. I encode it for, I return the NumPy or the Python list. This is just for, because I have like a save feature, and I'm not saving the NumPy setup. So where's the PDF specific for llama? Oh no, so I'm gonna go to that script real quick. So it's not so much specific to llama. Let me show you how I set it up. I called it Jared LLM. Because it's like, oh yeah, let me show you that data set I have. It's so funny. It's so funny. This is the data set. So I like scraped all of, so like I have like each, these are like some projects I have. This is like a Hacker News topic search, or a topic scraper, and like this is my algorithm thing I made, and I give it a description, and my data set is these prompts where I have Jared task, Jared description, the name of the file, and then the code in the file, and then the code is going to be the thing is the completion. So I feed it this on inference. Anyway, so all it is this code was working for fine tuning it. Maybe I should just give you this Colab, because where is it? Oh, this is old. Hold on. I'm not doing it like that. Yeah, right here. So I just load up llama like this. So the PFT, it's more that you get the PFT. They just have a function that uses your config to transform this model, where it just freezes whatever layers. I don't know if you can actually control how many layers it freezes or anything like that. I don't know a lot about that. But this is all you give it. And then the bias, you just say, yeah, you don't want it to fine tune to the bias, so ignore the bias. You apply dropout, tell it the R, the scaling factor, and then this is all you need to do. And the PFT, you just get this, you just import this from Hugging Face. Does that make sense? Like, oh, you freeze all layers, and oh, interesting. I don't know how you do that, because this just automatically unfreezes, like, or this just automatically freezes most layers except for, I think, like 3 of the last layers I read somewhere, or the last few layers. This does a lot. You're probably doing a lot of things more manual than I'm even doing here. Like I just load up the tokenizer, and then I load up the pre-trained model, and then I say load an 8-bit, and then I run this, and then I just have these training arguments, and then yeah, I use float 16, Yeah, ignore this. Just the run name. And then the trainer. This is the training loop right here. It's just the Hugging Face .train. So integer 8-bit is probably not possible. Oh, really? Well, that's also, you don't have to do that here. You can set it to false. Why is that not possible for you? Paste your Colab in here. Let me share. I should share all these collabs. I don't know why I'm not. I'm gonna share the collab for this video too. Yeah, I'm just gonna link the collab for all these. Let me just do anyone with link. Okay. So let's see. Tell me if this works. Let me know if that works. Issues on the server. Oh, okay. Interesting. Yeah, I didn't have any. The only issue I had was I have to do this. It was my buddy was telling me how this worked. I didn't fully understand this, but it doesn't do context level generation. So after it's fine tuned, it does this. It does token to token. So I have to do a loop here where I pass in the new the generated text. I actually don't have to decode it. I could just get the new generated IDs, I'm pretty sure. And but yeah, so I have to like do many generate functions per token, which kind of sucks. That's the only thing. Yeah. Oh, it works? Nice. I'm gonna add that to the description. I gotta remember. I gotta add that to the description. I also gotta add this one to the description too. But yeah, so I should probably open sources as like a super simple retriever reader model, or like just the most simple retriever reader library you could use. Just chunking and encoding with sentence transformers, and that's it. And reading too. So anyway, so it creates. So we have the encoder, and then we have the index builder, which builds the index of documents. We're just going to pass in one document, and then we're going to say we're going to create the chunks, which I just do this thing where this is assuming we have many docs. We're just going to have one doc, but I just get all the docs and I reduce them all into one flat array, and then for each doc I embed everything, and then I add the embeddings to the, oh wait, no, this doesn't flatten it. This just gets the chunk count. Yeah, never mind. But anyway, so I add all the chunk string and the embedding to an index, all in memory for now. You can put in PG vector, whatever you want. Extend this to do whatever you want. I know I need multiple screens. That's the next thing I need to do. Yeah, that's so funny. I've like, every job I've worked, people have been like, why do you only have one screen? And I'm like, I don't know, it just makes sense to me. Alright, so, and then I have this save index function. Then I have, okay, the reader class, for now, when I say reader, I just mean the prompt. So I build a prompt using the found context. So I pass in contexts. So this is for context. Why am I looping here? I don't know why I'm looping here. Oh, because it does it for the first context. This doesn't need to be a loop. But I actually took this from Llama Index. Because that's what their prompt is. We can make this whatever we want though. And here, so I have a query here that's like using the inference API. So let me just rename this API query. We want to have our own local query, which is going to be a whole thing. Let's just pass this for now. And then this is the magic, right? This is the retriever magic. So this is where we're encoding. We get the encoder for the query. It's super simple, right? We loop through every document. We get the similarity score using the dot score. From the query to every chunk that we chunk, we get the similarity. We add it. This is just basic. This is the vector database basics retrieval. The most basic retrieval. We're just getting, and then we say top n. So it's just if you want to get the top 3, just doing that, and then we return the sorted similarity. There's retorted docs by similarity. No, I'm not on Twitch. I probably should go on Twitch. Yeah, I should set that up. I mean, this was also knee jerk 2 weeks ago. I gotta like now do. Yeah, I gotta like stream on Twitch and YouTube at the same time. I gotta figure out how to do that. Only real 10x engineers stream on Twitch. If you're on YouTube, you're like, you're barely a junior. All right, so now, we can actually, we have our text, so we can actually start doing the retriever. So let's just do everything from the top. So let's go. So we have the document. So we want to get the document from the file, so we can load doc from file. Super easy. And actually, let's just go here, and I'm going to say and d dot load doc from file output.text is our whisper output from our George Hotz podcast. And let me just make sure there's nothing else that pass. Yeah, no, we only have quarks here, so yeah, that's it. All right, cool. So all we have to do is we load that document. So we have our document in D, and then we can create a class to build our index. In the index, we have to create our encoder first and pass that to it. So, and this is just going to be in the default encoder is the sentence. This like it's a very popular question answering embedding model here. It's very good for question answering and dot score, as you see, because that's how it was trained for those purposes. And this encoder, we're just gonna get the default encoder. We're gonna create an index from index builder. And index builder, you pass in the encoder. This is all stuff. I really just wrote these classes just to kind of make it as simple as possible, so people can just have like, yeah, it doesn't. This is a positional argument, but and then this is so we just have one doc. Let's run this. And what is it running? Is it actually running? Oh, something broke. Index builder is not defined. That's because I didn't run the cell. My bad. And oh wait, this has indentation. It's one problem with Python. Okay, so wait, that indentation, that didn't fix it. Okay, I'm gonna copy this because apparently tabs don't work. I'm gonna copy and paste this indentation, and then copy and then paste. That's so hilarious. All right, so we need to save that, and then we need to save this one. Okay. So this should take a little bit, cause it did not take at all long. Oh right, because we have to run. I made this create index function, which will actually create the index and keep it saved locally. So we're gonna do index.create index, and I'm gonna see if there's anything passed to create index. Nope. And this should keep. Oh, that's not good. There shouldn't be 0 chunks. Alright, so where do we go wrong? So we loaded this doc from file in our document, and I think we need to run chunk doc. Just want to make sure. Yeah, we didn't actually chunk it. I don't even know how my own thing works. And the default's 5 sentences, which is fine. Let's just keep that. Okay, cool. So now it's actually, so there's 628 chunks. Cool. So now let's actually, so we have enough to, let's get the retriever model. We'll worry about the reader part in a sec. For now, let's get the retriever model. So retriever, and you pass in the index and the encoder. So the index and then the encoder is E, and then retriever dot similarity search, and the query will be, I spelled. The query will be, what's this podcast about? So they talk about self-driving, AI safety. So let's just ask, like, what is, so like, what are some problems with self-driving cars? I don't know why I capitalized that. Oh, why did it break? Index builder is not iterable. Oh. You know why? I'm passing the wrong thing to this. I need to pass in this. Yeah. I made this kind of weird. I may have to update this. I should just pass in the class rather than passing in the. Let's see, how is it? Yeah. I shouldn't do that. I should make it pass in the class. We'll just do this for now, but. It's still broke. What? No. Expected all tensors. No. Expected all tensors to be the same device but sound 2 devices. Okay, so for some reason I created some of these I don't know which one is CPU. Can I do that? Is that gonna work? One of these. Okay, no. 2 CPU. I hate that error. I hate that error so much. Okay, alright, cool. Let's not log all those numbers. Ugh, gross. Whoa. Alright, so we officially have our retriever for our ChatGPT bot. So I asked, what are problems with self-driving? He's like, we solved it years ago. What's the problem exactly? Well, what does solving it mean? Solving it means, how do you build a model that outputs a human policy for driving? How do you... Oh, this is actually like the answer. Nice. So we're at least retrieving the answer that we will now pass to llama to answer the question. So let's now load up llama and see if we can start doing stuff. So what we're gonna do is we're gonna prompt llama 2 with this information. I'm actually gonna use the same thing. We're not gonna fine tune it, so we don't need to do any of that. All we need to do is this, pretty much. We don't have to prepare it for training. We don't have to do any training at all. We just need to get the tokenizer. We have to get the auto tokenizer. Hold on a second. Okay, so from transformers import auto tokenizer. Is that gonna work? Oh shit. Token is required, but no token found. Oh, I didn't log into Hugging Face. I gotta go to Hugging Face. Don't mind me. I gotta go get my access token. You won't see it though. Don't mind me. I do need to get multiple monitors, by the way. That's like next step. That's like I'm graduated. I'm a full man. The Vikings would lift different sized rocks in order to see. Wait, invalid token passed. But they use these let me just make sure I copy the right token. But they use these rocks to see who could lift the rocks and who was allowed to work on these ships. And the big rock, the small rock, you were like a pipsqueak. The medium rock, you were called a half man, and the big rock, you were called a full man. Once I get 2 monitors, I'll be a full man. Alright. Okay, so I loaded the tokenizer, and this is just for testing for now. We're going to want to actually organize our code in a way that we can load our model with the class, so we can design it for an asynchronous setup, which I'll talk about why that's important. Oh, accelerator. Oh, I forgot to install accelerate. I'm gonna install that at the top. Pip install accelerate. Alright. So let's see if... Oh, actually, I don't know if I imported accelerator. I had to have, yeah. from accelerate, import accelerator. I gotta get my imports in check. Hold on. So I gotta import this. So I have the tokenizer. I have the model. The model, this is the only line you need. And as you saw yesterday, we have a casual model. So we have this decoder, autoregressive, GPT-like model, as opposed to a masked model. And I think we have to import this as well. Do we need auto config? I don't think so. I should just do my imports all in one place, I know. Formers import. So let's run that. Then let's run this. Use cat. Whoa, there's an error? Why would there be errors? Wouldn't everything just work? It says I'm using accelerate. Why would it say that I need accelerate if I'm using it? What? That doesn't even make sense. Oh, am I not importing? No, I am importing it. I'm not missing it. So something else is wrong here. I had this error before. I totally forgot how I dealt with this. I had this error before. Is it because there's something else I needed to install? No. And I import this, trainable parameters, start iteration. That's interesting. I don't know why. Could you 8-bit equals false and see where who am I talking to? I'm talking to myself, dude. But could you 8-bit equals false and see whether it still fits? Interesting. I think you're right. Let's see. No. Oh, it's the device map that it's freaking out about. Why would it work over here, but it wouldn't work here? If your import is failing and missing, you can. I know I have it installed. We may have to look this up. Nah, I mean, I know I just installed it. It's spelled right? Accelerate. Yeah, it's spelled right. Gotta look this up. Because I know I have it installed. Tony, do you know this? Yeah, Google it. Yeah, I know. PyTorch requires. Oh, pff. They said restarting the runtime after you that sucks. That sucks. I'm not doing that. Let me just run this with you. Yeah, it's just, requirement already satisfied. Restarting the runtime? Boo. You know what I can do? I don't know if, Tony, do you know this little trick? Where you kill the the process ID on Colab, instead of, it's a way you can restart your session without while keeping your file system intact, so you don't have to redo everything. So I'm gonna go. You don't keep the runtime though, so like you won't keep everything in memory, but you'll keep the file system, so you don't have to reinstall everything and re-download the models and everything. Yeah, I had that bits and bytes issue too. I might have to install bits and bytes. I think that might be the thing. Oh, interesting. I'm still gonna have to load up. Oh no, I have all my data. So I don't even need to do that. All I need to do is start from here and get my document class, get my encoder class. Yeah, I think I have to install I think the bits and byte might fix this. And then retriever. Then yeah, but yeah, for whatever reason, when you I don't know why, but when you delete the process, they have some sort of automatic process to restart to the runtime automatically, but it keeps the file system. But when you delete and reset it, it'll just, as you probably know, you'll lose everything. All right, let's see if, okay, cool. That's still working. I think I don't need to relog in to Hugging Face, but I do need to get this tokenizer, import the accelerator, and then run this. Let's see if this works. No, it's broken. Alright, now I'm getting the bits and bytes issue. So now I need to get bits and bytes. Just want to get to a point where we can use one of these contexts to get a prompt and use our prompt to get back an answer, some sort of answer. Okay, bits and bytes is installed. And let's run this again. Still have an error. Let me see if, so maybe I need to get the most recent install, which is this. Yeah. Let's see. I also may need to restart this whole process. Oh, this errored out. No. You know what? I'm gonna restart the process. For some reason, I don't know why I have to restart that. That's super weird. But I think I do have to restart it. Okay, let's load this up again into memory. Document. Encoder. Our index builder. The index builder is our array of embeddings, or it embeds our array of chunks into an embeddings database, a vector database. The retriever is doing the similarity search. Let's create the index. Try out Colab's so flawed. I do need to try out. Is Kaggle free? Okay. 128 gigabytes of TPU. That's pretty good. That's awesome. Is that free? Base. Okay, tokenizer. Accelerate. This better work. Okay, alright, we're actually loading a model now. Nice. I want to see some. Okay, cool. And this is a smaller model, so this is a 7 billion parameter one. Cool, so now we can. I'm going to take my. Oh, actually, because we're not using PFT, we don't have to do this token to token generation thing. I'm pretty sure we literally just need to do this. Let me just, I want to double check. Where is this? Oh, right here. Did that already load the model? Are you serious? That's crazy. Yeah. Oh, okay. 12 billion, 128 TP, 20 hours per week. That's not bad at all. Wow, that's not bad at all. Is that what you use? Or you use the college computer, right? Oh, I need to get the generation config from here. I actually like the generation config. I know it seems a little clunky, but there's so many parameters that are like being developed for LLM generation. So I just like that. And let me do max new tokens like 20. Let's do 20. Let's do like 40. Okay, so the prompt is. Oh, the prompt is the same question we asked. Oh no, the prompt is we have this little. Where's the reader? So we have this like build question prompt thing. Okay, so let me figure out how to do this. So I need to get a reader. Hold on a sec. So I get my reader and I initialize it with, actually don't know, what do I initialize this with? Nothing. And then I use .build question prompt. And then prompt equals, and we'll do this generation stuff. We'll make some sort of class method to deal with all this. This is kind of a whole thing actually. Figuring out how to set that up. So so the question, which we didn't define yet, and then the context, which is, I don't think we put the context in a variable. Yeah. Let's rerun this. Let's X out of that. So make it easier to scroll here. Question, we gotta define the question. Question equals. Whoa, whoops. Then question. All right. Let's run this, and nice. So let's go, and I think we can run it now. So let's get the prompt. So let me print out this prompt. It says none. What? Oh, because there's no context in here. So context. This is the array that we're getting back from the retriever, from the similarity search. All right. Oh, I don't know if user assistant, if these are the right tokens. Well, but it looks good though. Let's see if this actually works. Hold on a sec here. If we get some generated text. Oh, I didn't print anything. My bad. At least we didn't get an error though. Okay. Look at this. Look at that. Look at that. We just, even though it's cut off because the token count is limited. Let me actually change this to like 128. We'll have to figure out how to parse all that. Nice. We just made a ChatGPT like question answer off of podcast text, off of podcast transcript. We scraped the data from the podcast. We got encoded the transcript from the audio file. We built up a retriever using from our own custom retriever. Well, I wrote it like a week ago, so it's not that impressive. But we chunked the podcast test. We made a vector database on it. We built a retriever to get us the prompt, put it in the context that we want, and then now we actually answered it. So I asked it, what are some problems with self-driving cars? I used the context from the podcast, and this is our answer. It says, 1, the cost of the self-driving cars can be very expensive, especially compared to traditional vehicles. The lack of infrastructure, many roads and highways don't have. All right, yeah. So it's answering it. I want to see if there's anything in the context. It actually doesn't like say use anything from the context in the answer, so I don't know how much of this answer is actually used. I don't know, but at least it's doing something. PyTorch. Yeah, you use that. Yeah, I need to start using Kaggle and getting into that. So, does Kaggle? Let's ask another question. We can streamline this later, but now I'm just happy we have this working. It just reset the. See, this is why I don't like. I really need to use Kaggle because it just reset everything from the Colab. That's cool. I'm glad completing your projects matters. We said we're gonna make ChatGPT like AI. We did it. We're using Llama 2 to run inference. I'm unsure if it's actually working well, but it at least answered the question. The thing is, we didn't use enough data. But so the next steps are building out these retriever reader classes, so that the reader can actually be all this stuff we wrote out to load up the model. What I've found building a product right now that uses large models in production is you have to really think about, especially you really think about the uptime for your models and how, and having a cached model available while the server's resetting, so that you don't, re-download the whole Hugging Face model every time your server resets. Because the thing about server architecture is your server's going to have to reset a lot, and you don't want a ton of different especially in the distributed realm, you don't want to have a ton of different servers, forked servers, dependent on a you want them to be slaves to a master that is in control of things like your AI model. You don't want that data to be dependent on the uptime of these front end servers, because front end servers are they just get reset. That's just a thing of life, is they get reset. But we did it. So let's actually, what else is this podcast about? It's about AI safety. Maybe so let's ask another question. What are some issues with AI safety? So I got the contexts. Let me get my prompt. Let me see if my prompt looks good. So he says, the thing that worries me, we have a real danger to discuss, is that bad humans using thing to do whatever bad unaligned AI thing you might want. But this goes to your previous concerns that who gets to define who's a good human, who's a bad human. Nobody does. So that's actually like a really good. So the question answering, I love this question answering sentence transformer model, because it actually is really good. This is the answer, right, to AI safety. And you don't need, like, everyone thinks you need OpenAI embeddings for everything. OpenAI embeddings are overkill. This is like a 200 megabyte model, for the sentence transformers. Llama is a different story. Llama is like, 30 gigs or so. Or I don't know, it's pretty large. All right, let's generate some text. Remember, the PFT one, that's token to token, so you're going to have to do that loop per token. This one's not using PFT because we're just running inference on the, we're not fine-tuning anything. It would be faster, though, if we did, because this isn't that fast. Okay, so I got my answer. Let's look at this answer. 100 plus researchers and 33 institutes work on AI safety, and over what? Project Mind Control. Programmer Dana Gertz Viatova. Dana had an idea to let users control people's minds by writing text prompts, thinking. Okay, what the fuck? I don't know what this answer is. This answer is not. Did you see that answer? This answer is not informed by the context. We got to figure out the llama prompt that we have here, because I don't think this is the right prompt for llama for question answer, for context, user assistance and all that. It says I ask it, what are some issues with AI safety? I give it some context from the podcast, and it just talks about how 100 plus researchers and 30. It talks about Project Mind Control. What? Let me. Repetition policy. Top K. Top K is fine. I don't want it to be too small. Temperature. Let's do temperature 7. Let's actually make the repetition policy 0.05. Anything over 1 is negative, I think. Let's get the prompt. Oh yeah, it's the same prompt. Alright, let's do this with the new generation config. Generated IDs. This is taking a bit, actually. Yeah, it's it's crazy. Like, why would that be the answer? All right. AI safety is a field of research focused on preventing potential harm caused by AI, and it covers a wide. Yeah. Okay. All right. Whatever. We need better. I need to know more about this podcast. No, I'm gonna look up prefix tuning llama 2. Or no, wait. I just want to see, not prefix tune. I just want to use instruction. I just don't know. No fine tuning. I want to see how they train question answers. Okay, so how to prompt llama 2. Okay, so yeah, I'm not even doing the system prompt right. Okay, user message. So this is how it works. So prompting matters. Instruction system prompt. I don't know if I need all this. Anyway, then that's the end of that, and then the context. I don't know how to add context. Do they talk about that here? So user message. Okay, this is cool. I like this format. It's actually a cool format. I think maybe next time we get a few things to do next time. Implement the system prompting. I'll leave a little cliffhanger so we can continue with this, getting this going, or we have other videos we gotta finish. I'm doing a lot of different topics just to sort of see. Someone recommended on one of the previous streams to go into llama 2. I hope you're satisfied, whoever asked that, because this is a whole llama arc that I'm doing right now. Alright. But we did a lot though. So next thing, we have to utilize these system prompts to essentially make this better. We did it, but we didn't do it well. So we have to implement these system prompts to do it well. We can also go back into fine tuning the code like me script. So we'll see. We'll see which one we go back to. The code like me one is a cool project, but I like this podcast thing angle. This podcast angle is very cool. But alright. Ending the stream. I'll see you later. See you, Tony. Let me know if you want to code tomorrow. Nick and I are going to be at a cafe coding. We code every day. That's what 10x engineers do. That's what 10x, you code every day. If you don't code every day, you're 1x. You're not even close to 2x if you don't code every day. All right, see you, man.